Hey guys, how's everybody today? In this video, we're going to start taking a look at MPLS Layer 3 VPN. Actually, let me just say Layer 3 VPN, and let me just explain a few things. Layer 3 VPN is actually a combination of a few different things. It's a combination of MPLS, so typically this is going to be LDP. In fact, that's what we're going to talk about in this video. It's a combination of multi-protocol BGP, specifically, the address family that you're actually going to run, whether it be IPv4 or IPv6, but this is going to include your VRF AFI as well as your VPN AFI. And a lot of people get these confused. A lot of people forget that no matter what they run between their CE and their PE, they need both. And I'll show you what I mean as we actually configure this. And then we're going to need a VRF. Now, the virtual routing and forwarding instance is essentially going to be configured on the service provider facing the customer, because as these routes come in, we're going to want them to go into their own VRF. Now, the last thing, and let me put this in a different color, the last thing is typically an IGP of some kind. Now, I've seen people run Layer 3 VPNs using static routing, so you just have a static route that points, everything this way. I've seen I've seen many different ways that people have configured this. I've seen ISIS, I've seen RIP, again, static routing, so you have a static route that points everything out this way. I've seen static routes that point, things back in this way, meaning static VRF routes. So on the service provider, it'll say, look, for subnet 192.168, blah, 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 go to this next hop. For subnet 10.1, go to this next hop. So I've seen static routes, I've seen all sorts of stuff. But generally speaking, the best way is to use some type of dynamic protocol between the CE and the PE to make everything happy and hunky-dory. Now, before I go into the config, I want to mention that I want to try to keep this video as short as possible to essentially teach you guys how to actually set this up and how to configure it. There's going to be a lot of stuff that I leave out in this video. I'm going to be leaving out the label exchange between LDP. So in other words, the full label exchange that goes on between these guys, I'm going to be leaving that out. Or I'll probably mention it, but I won't go into great depths. I'm not going to go into great depths into things like the route distinguisher and the route targets, how these guys are extended communities. I'm not going to go into a whole bunch of the theory end of this. What I will try to explain essentially how it works, but my main goal of this video is to teach you guys essentially how to get your routes, your subnets from this customer over to this customer. That's the primary focus of this video. So if we leave out the theory, don't worry. I will have a separate, layer 3 VPN video series that goes through all the nitty-gritty, all the little details, okay? This is just for YouTube, if you will. So this router here and this router here are going to be what we would call our customer edge devices. Now, normally some people may get confused and say, well, aren't they your customers? You could consider them customers if these guys were the customer edge. We're going to assume that off of here we have a subnet or we have some layer 3 devices that are running off of here. You could also be doing sub interfaces off of your edge router, and then it would be kind of it would be a customer/customer edge combo. So that's kind of what we're going to do here between R6 and R7. Then we're going to be running a PE device on router 4 and router 5. So these guys here are going to be our PEs. And then router 1, 2, and 3 are going to be our providers. So this here essentially is going to be going back into our provider network. Now for an IGP, in order for LDP and MPLS to essentially work, we have to have full reachability throughout our provider network. So for the IGP, we're going to be using OSPF. I could use ISIS, and many people do use IS to IS in their service provider network or in their core. Completely fine. ISIS is a great protocol. The reason why I'm using OSPF is because not that many people are familiar with ISIS, and I don't want it to be confusing. I want you guys to understand essentially as much as you can, so I'm going to use OSPF. I would not use EIGRP in my provider network. You can use it. There's no problem with using it. Depending on where you go and what you do with Layer 3 VPN, there could be issues. But for this video, you won't have issues using any protocol you want. You could use EIGRP, you could use RIP for all I care. The idea here is that you need to have reachability between the loopback addresses of these devices, because we're going to use that as the LDP router ID. Now, the LDP router ID has to be reachable because these are going to be IPs that LDP actually uses to form an LDP adjacency. So that's why they need to be reachable. Okay, so everything's going to be in OSPF area 0. And we're going to run point-to-point interfaces between these guys. So here's the objective here. So here's what's going to happen. The routes that come in from router 6 are going to hit the PE router and router 4. These guys are going to be dropped into a VRF. And by the way, we're going to run EIGRP on our network on both sides. Okay, so both of these guys are going to get dropped into a VRF. So EIGRP here will be in its raw state, and then EIGRP here will be in this VRF. Okay. Once we're inside of this VRF, you have to think it through. Think of how this is going to operate. You've dropped these routes into a VRF. Well, in order to get them from one PE to the other across the service provider network, you have to be able to essentially keep them, if you will, inside of that VRF. And I'm trying to, again, not give away a lot of the details and go too deep into it and make this video an hour and 40 minutes. So we need a BGP instance of the same VRF. So these routes are going to come into EIGRP VRF, and then they're going to be dropped into a BGP VRF. They're going to go from here into here. So yes, you are going to do redistribution here, okay, between EIGRP and BGP on the PE router, okay, on both sides. Now, these prefixes are now unique because we've assigned these route distinguishers, and remember they're route distinguishers that are going to get prepended to your prefix, so you have 10 blah, 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 right? So now this route distinguisher is prepended to that prefix. Now what you're going to do is you need to get these routes that are now sitting here on router 5 all the way across the network, which could be 1,000 devices, over to router 4. Well, how do we do that? Well, we're going to use multi-protocol BGP. First of all, we're already using it for the VRF, but we're going to use a VPN address family, so I'll say AFI address family, in order to take these routes and essentially pass them to the other PE. So they're going to go from the EIGRP VRF into the VRF for BGP, into the VPN address family, and then they will get essentially advertised between these two guys. And that's what the route targets are for. The VPN adjacency between router 4 and router 5 carry these route target values so that router 4 and router 5 know what routes they need to take. They know what routes are for them and what routes essentially they don't have a VRF for, and so they can ignore, they don't care about. That's what the VPN address family is for. And a lot of people forget this tri-hop, right? So they forget we go into the IGP VRF, we go into the BGP VRF, and then what BGP does on its own is it's able through this VPN address family to essentially allow these route targets to be advertised between these guys so that router 4 and router 5 know what routes they want to choose. Now, there is more to it than that. So those of you folks that know maybe a little bit more in depth the theory, don't bark, don't say, well, but there's this and this. Yeah, I know there's a lot more to it than this, but again, in this video, I'm just trying to explain how to configure it so that essentially you can do it with a little bit more ease as you get deeper into the theory, okay? So let me just quickly redraw this and let's get it done. So we're going to do EIGRP here, okay? Then we're going to go into, we'll say BGP here. And then we're going to have that VPN address family. So let's say VPN AFI here. And then we're going to go back the other way. So we'll say BGP, back over to here, EIGRP, back over to here. So that's essentially how this works. Now on the service provider core, remember, we're going to run OSPF. Everything's going to be in area 0. We'll run point-to-points between, and we're going to run LDP as our label distribution protocol, right? You could use TDP also, but I wouldn't recommend it. Now, you may see some cleanup stuff that I've done over here. Just kind of ignore that. Not really a big deal. This was some stuff that I had previously configured on my network. So let me walk you through my configuration. The first thing I do is I say no MPLS IP. That's just in case somebody's left it globally enabled, because there's two places we have to enable LDP. We enable it on the interface. So we have to enable LDP both here as well as globally. You have to enable it twice, okay? So be careful. Many people get confused here. I'm going to say MPLS LDP router ID, And I'm going to manually assign this to loopback 0. So let me say do show IP interface brief E assigned. And every device is going to have a loopback 0, which is essentially the same as the router number, and it's a /32. So router 3 would have 3.3.3. So I manually assign my router ID to that loopback. Remember that it has to be reachable via TCP, and that's port 646. Okay, it's UDP and TCP, but just remember 646, you'll be okay. Now, let's see, we'll do MPLS label range. Now by default, let me hit the question mark here. By default, your devices, when you enable LDP, are going to start assigning labels from 16 to 1 million. But I don't like that because it makes it very difficult to troubleshoot. I mean, imagine if router 3 has label 47 and you go to router 1 and you look at the same prefix and it says label 47, your mind gets all sorts of fun confused. Once you understand it, it's not so bad, but when you're first learning it, it's like your mind explodes. So I generally pick a label range, especially when I'm labbing, I pick a label range that matches something to do with the router ID. So for in this case, I'll say 1000 to 1999. Okay, so what's going to happen is that for me on router 1, when I start assigning labels, I'm only going to assign labels from this range. Of course, when you use this command, you have to make sure that you're assigning enough labels for the amount of prefixes you're actually going to have. If I have 2,000 prefixes, if I have 3,000 prefixes, this is not going to do me any good. I have to create the label range for what I expect. Okay, but if you're labbing just a simple lab like this, 999 labels should be more than enough. Now we'll globally enable it and say MPLS IP. Now let me show you the reason I'm using OSPF or ISIS in this configuration. So we'll say router ID 1.1.1. Again, I manually assign this. LDP has basically the same router ID mechanism that OSPF has when choosing the router ID. So the highest loopback address followed by the highest interface IP address, I think is what it is. But again, I manually assign these because I like to do that. I like the control. So we'll say do show IP interface brief E assigned, and we're going to do this on E00 and 1. So I'm going to say interface range E00 to 1. And I'm going to say IP OSPF network point to point. That way we don't have to deal with the assignment of the DR and the BDR. We'll say area 0, and I'll go ahead and enable it on this interface as well. Copy and paste this. Say redistribute connected subnets. And this is the golden command, MPLS LDP auto config. And you have to type it right. Now at this point, let me say show MPLS LDP discovery, and you can see that at this point we're now transmitting LDP packets on those two interfaces because MPLS auto config here under OSPF automatically enables LDP for us on any interface that's been added into our OSPF process. So it makes our life very, very easy. So let's go on router 2, we'll do the same thing. So we'll say no MPLS IP, MPLS LDP router ID, L0, MPLS label range, and I'm going to say 2000 to 2999, MPLS IP to enable it globally, interface range E00 to 1, IP OSPF network point to point. We'll actually shut down the interface that goes onto that switch to not cause issues for ourselves. Router OSPF 1, router ID 2.2.2, and do show IP interface brief E assigned network. We're going to do this guy. And we're going to do this guy. Oops. Redistribute connected subnets and MPLS LDP auto config. Let's check router 3. So we'll say interface E02. We'll shut that guy down. Interface range E00 to 1. IP OSPF network point to point. I'm having typos galore here. And let's do our MPLS config. So no MPLS IP. Again, it's just a habit. You don't have to turn it off. It's just a habit. If it has been left on, if somebody turned it on, I think in some versions of code, it was on by default at one point. I don't know if it still is. So it's kind of like no auto summary in EIGRP named mode. Many people have become, have just built that habit to say no auto, even though it's disabled by default. Let me actually see these notifications over here. We can see that router 1 now has a full OSPF adjacency, but it also has an LDP adjacency. So let's pause and let's check that out. Show MPLS LDP discovery one more time. You can see that on E01, which goes down to router 3, we're still transmitting, but you can see that now we're also receiving. Right, so now we're transmitting and we're receiving on this interface via LDP, and we have a neighbor 2.2.2. Let's say show MPLS LDP neighbor, and you can see that we have a full neighborship. And again, there's our 646 ports. So we can see that router 2 was essentially talking at the higher random, so 41.647, and the destination port was 646. So let that be a lesson if you guys are creating ACLs or you're troubleshooting certain things, you have to have that port open. But the thing is that look at the source and destination IP addresses. It's the router ID that we actually used in our configuration. So router 1 and router 2 are actually talking to each other to the router ID and from the router ID. So if the RID, if the RID is not reachable that you're using for LDP, LDP is going to fail. Okay? So let's go to 2. We should see the same thing. We should see show MPLS LDP discovery. We're transmitting and receiving. Let's backspace this guy out. We'll say neighbor. And we see the same same bits of information. Okay, again, I'm not going to dig through this because this is more of a get it configured and get you guys going, get you guys out of the mud, not more of a let's dig through all the nitty-gritty details. Okay, so let's say MPLS LDP router ID, we'll say L0, MPLS LDP label range, whoops, label spell JP, label range. And I'm going to say 3,000 to 3999. I missed a 0 there. Okay, MPLS IP. Let's say router, OSPF router 1, and we'll say router ID 3.3.3. And do show IP interface brief E assigned. Let's enable it on the networks here between router 5. And we'll enable it also between router 1, redistribute connected subnets, and MPLS LDP auto. Now, I should also see, let's say show MPLS LDP bindings, spell right, LDP bindings. And what you're seeing here is what I would call the full label exchange. Now, I said I wasn't going to get too much into it, but as I'm thinking about it, you know, I'm going to kind of have to explain a little bit what's going on here. LDP is going to have a full label exchange between the peers, between the neighbors. So essentially what's going to happen is that router 1 is going to have a rib. And he's going to have all these prefixes listed in his rib. And what he's going to do is he's going to define a label for each one of these, okay? Even if these prefixes have been advertised. So what's happening here, let's take this prefix, for example. Router 2 says, hey, here's my loopback 2.2.2.2. Well, router 1 knows about that prefix because he's learning about it through OSPF, right? And so what happens is on router 1 is going to assign a label for everything that's in his local routing table, including routes that he's learned. So this is the locally generated label that router 1 has said, yes, great, thanks. I'm going to generate a label for that. Well, router 2 is also going to generate a label for every label in his routing table, which of course includes 2.2.2, his own label, but then we have a full label exchange. So router 1 tells router 2, hey, here's all of my labels. Router 2 tells router 1, hey, here's all of my labels. And so you see here that router 2 generated the implicit null label for his own prefix, which makes sense because he's the essentially second to last hop to that loopback address, right? But now you see something strange too, is that you also see another remote label, and this guy came from router 3. Well, why is that? Well, because think about OSPF. Router 1 knows about 2.2.2 via OSPF, and router 1 advertises that prefix to router 3. Well, router 3 did the same thing as router 1 did. He generated a label for everything that he knew about in his routing table that included 2.2.2. And so the label that router 3 generated was 3001. But you may say to yourself, this does not make any sense whatsoever, because why in the world would router 1, and I cleared the screen to make it easier to read, why in the world would router 1 send traffic to a label of 3001 to get to router 2? We already disabled these links, right? That doesn't make any sense at all. And that's where we look at the CEF table, and you look at the rib, you look at the bindings, oops, we'll say bindings, you look at the CEF table, and you look at the rib, and you come out with something called the forwarding table. Now, the MPLS forwarding table is what makes sense of all of this nonsense. So when we look at the forwarding table, so if I say show MPLS forwarding table, you're going to see a simplified version of essentially that information. So you're going to see what actually makes sense. So here, if we look here, I'm not going to get into too deep what PHP is, the penultimate hop popping. It's essentially when we pop off the label, the outer label, when we're forwarding traffic. So here you can see that router 2 gave us a label of implicit null. He's telling us, hey, pop the label when you send me this traffic so that I can perform a regular IP lookup, right? So again, why would I send traffic to myself? Why would I send traffic to router 3? That doesn't make sense. Well, the forwarding table goes and digests all of our physical information, things in our Ceph table. It looks at our routing table and it says, okay, look, I am going to pop this label. Whenever I receive traffic for 1004, I am going to pop this label. I am going to send it for this prefix. I am going to send it this interface towards this next hop. So the next hop would be 10.1.2.2, which is router 2. The outgoing interface would be E00 for this prefix. And what's the function that I'm going to perform? I'm going to pop the label. So that's exactly what the binding table is, just essentially looking at all of the labels that have been assigned for the prefixes in our routing table. The forwarding table is actually telling us what we should do, okay? So let's go to router 3. Let's finish our configuration. I think we should be done, and this will become more clear as we trace routes. If what I said here wasn't clear, we'll take a look at it in just another minute or so, okay? As soon as we're done with our config. So let's say show MPLS LDP discovery. Good. So now we have to configure router 5. So let's jump and we'll do that on router 5. So config T, no MPLS IP, MPLS LDP router ID L0, MPLS label range, and we're going to say 5,000 to 5999, MPLS IP, interface E02. We'll shut this down, and I'm going to say interface E00, IP OSPF network point to point. Now here's the thing. On router 5, the PE routers, let me jot this back down again so that you guys essentially don't forget. These guys are going to be the PE routers. These guys are all P routers. And these guys here are going to be the CE or CE combo. Okay? So we don't want OSPF running between 5 and 7 because remember, this guy here, this link here is going to be our customer link. This is facing the customer. We don't want our global ISP process running on that interface. So let's exit out. We'll say router OSPF 1, router ID 5.5.5, network, I'll do show IP interface brief, E assigned, network 10.355.0.0.0. 0, redistribute connected subnets, MPLS LDP auto. Let's do the same thing on 4. And MPLS LDP router ID. I could type L0 MPLS label range, and we're going to say 4,000 to 499, 49.99. MPLS IP. Let's shut this link down. Let's put this link in a point-to-point. Router OSPF 1, router ID 4.4.4, and do show IP interface brief E assigned network. By the way, in case you're wondering why don't I just type this in, it's a habit because this way I don't make any typos in theory. Redistribute connected subnets and MPLS LDP auto config. Okay, let's go to, let's say do show IP OSPF neighbor. I didn't see a neighbor come up there, so what's going on? Let's say do show run interface E01. Did I accidentally shut it down? No. Let's check 2. No. Did I? Here, so let's go back and take a look at that in a minute. So we have an LDP neighborship that's up between router 5 and router 3. So let's say show IP OSPF neighbor, that's up. Show IP route OSPF, that's up. Let's say show MPLS LDP discovery, and that's up. Let's say show MPLS LDP bindings, so we can see all of our bindings here, and we should have a pretty good forwarding table. So show MPLS forwarding table, and we can see now that we have a good forwarding table between these guys. So let's go back over to 4 and 2 and see what's going on here. So let's say show run section router OSPF. Let me just check my config. That's good. Redistribute that's good. That's good. Show run interface E01. So point to point. All right, let me just pause the video quickly here, and we'll get this guy fixed. Okay, guys, we're all back. I had the incorrect network statement there. It's funny because I was saying I avoid typos, and I had the network statement right, just on the wrong interface. No big deal. Just took me a minute. It was staring at me in the face. So here we have it. Here, let's say do show IP interface. Do show IP OSPF neighbor, and we can see that router 2 is a full adjacency here between router 4 and router 2. So router 1, let's check a look here. We have a good size forwarding table now. So let's take a look at this here for a second. Let's say show IP route OSPF. Router 4 wants to send traffic to, let's say, the loopback address of router 5. So let's pick 5.5.5. What's he going to do with it? Let's say show MPLS forwarding table, and let's take a look and see if we can find 5.5.5. Well, what's he going to do with it? Well, when he sends it out, he has a local label of 4015. He's going to send it out, local label 2010, or I'm sorry, remote label 2010, for this prefix, right? And he's going to send it out, his E01 interface, with a next hop of 10.2.4.2. Does that make sense? Router 4 is going to send it out E01 with a label of 2010, okay? Remember, we had a full label exchange, so he's going to send it out with 2010, and he's going to send it to router 2. Let's check router 2. Let's see what router 2 is going to do with it. Now, at this point, let's stop looking at the prefix. Let's start looking at the labels, okay? So from here on in, forget the prefix 5.5.5. Let's look for the label 2010. So let's say show MPLS forwarding table, and let's look for 2010. There's 2010. Don't look at the prefix yet. Don't look at anything. 2010. What are we going to do with it? Well, we're going to send it out with a label of 1010. And when we do that, there's the prefix. Look, and when we do that, we're going to send it out of our Ethernet 00 interface toward the next hop of 10.1.2.1. Now remember, what I want to do is stop looking at all this information here, and I want to look for the label 1010. So where are we going to go? We're going to go with a label of 1010. So we're going to swap the label. Now, I didn't go into the popping and the swapping and the etc. because, again, this video is more of the how-to configuration. Just want to give you guys a little bit of information so you understand. So we're going to swap this, and we're going to put a label of 1010 on it, and we're going to send it out our E00 interface. So let's check now router 1. Remember that I picked the label range, so you can tell that all these were assigned from router 2, all these were assigned from router 1. Makes sense? So I'm going to go to router 1, and let's look for 1010. We actually already have it up. So here's 1010. What are we going to do with it? We're going to send it out with a label of 3010. We're going to send it out our E01 interface to the next hop of 10133. And what's the prefix? There it is. So let's go to router 3 and look at 310. Show MPLS forwarding table. Let's look for 310. There it is. What are we going to do? We're going to pop it. We're going to pop the label one hop early, right? Because router 5 is the second to last hop before the loop back address, right? So here we have router 5, or router 3 router is going to pop the label. We're going to send it out for this prefix at our Ethernet 00 to 10355. Okay, so that's how we label switch. Essentially, we're no longer looking at just the routing table. We're looking at all this information together, and we're actually going to follow these labels. So that's how this would work. Now that we have that taken care of, what we want to do is get EIGRP configured here, because I think we're already like a half hour into this thing. So let's say router EIGRP, SIFT. What is SIFT? Is that what I just said? Router EIGRP, and I'm going to say L3VPN. Address family, IPv4, autonomous system, 1, and we'll say network, what are we on, 6? So I'm going to say 10.4.6.6, all zeros, topology, base, redistribute connected. Okay, so there's our configuration for EIGRP. Let's actually grab this, and we'll go and we'll pop it on 7. Okay, and we'll say network, 5.7.7, and all zeros. Whoops. Okay, so now is where all the magic happens. We already have a perfectly functioning label switched path between our two PE routers, router 4 and router 5. We have EIGRP running between router 6 and router 7. So essentially at this point, all of the magic is going to happen between router 4 and router 5, because here's where we need router 4 and router 5 to receive the customer routes inside of a VRF, take those routes, put them into multi-protocol BGP, and then somehow get them from router 4 to router 5. So let's set that up. We'll say config T. I'm going to say IP VRF, and I'm going to go ahead and create a name. Now, I'm going to use two different methods for creating the VRF because, I don't know what you guys are used to. I'm assuming you guys want to learn all the methods, so I'm going to show you the old way as well as the new way, and there's also a command to convert from the old way to the new way, but that's another video another day. So I'm going to say IP VRF. We'll call this guy L3VPN. And I need to give this guy a route distinguisher. Remember that this is the value that essentially gives us a distinguished route, right? I mean, that route distinguisher makes sense. Now, what I'm going to do is I'm going to use a combination. So you see here where it says IP address followed by a number, and then we have ASN followed by a number. I normally use a Frankenstein where I do IP address followed by the ASN. Okay, so I'm going to do, let's see, router 4 is 10.4.6.0. colon, and our autonomous system at this point is 1. If it was 65,000 or 212, I would write 212 here so that I would know the ASN followed by the IP address or subnet. Now I'm also going to say the route target. Now, the route targets do not have to match between the PE routers. What has to match is whatever is being exported over here. So export needs to be import over here. Okay, let me do a different color. Whatever is export over here needs to be import over here. Okay, so that's how it needs to work. These values do not have to match, although you can make them match. They just have to match opposite, if that makes sense. So here, if I hit the question mark, you can see that my format is essentially the same, but they don't have to match. So what I'm going to do is I'm actually going to set my export value to match the route distinguisher that I'm using. So I'm going to say I want you to export that subnet followed by the ASN, right? But for the import, I'm going to use this subnet. So I'm going to say route target import, and I'm going to say 10.5.7.0 colon 1. So do show run section VRF. All right, so I'm going to import anything that comes from router 7, and I want to export router 6. Make sense? So now what I'm going to do is I need to assign this to the interface. The VRF has to be on the interface that essentially I'm going to face the customer with, which is our E00. I'm going to say interface E00, do show run interface E00. And the reason why I brought that up is because when we apply the VRF, it's going to peel this off. Now, there's two different ways to apply it depending on how you created it. IP VRF forwarding is the old way. If you were using the new way, which I'll show you later, it would be VRF forwarding. So if I hit the question mark here, it lets me know, hey, pop this VRF on. Once I do that, it says, hey, interface, blah, 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 removed due to enabling the VRF. This physical interface is no longer going to be in our global routing table. This physical interface is now going to be in this VRF. And so it peeled off the IP information so that it's now in that VRF. Let's say show VRF, and let's say show IP VRF. Same command, very subtle difference. The IP VRF is the older way that we would verify this, and it doesn't show us the protocol. It just shows us the route distinguisher, the interface, and the name of the VRF. The new way, which is using a VRF definition, allows us for multiple protocols, meaning IPv4 and IPv6. And so that's why this has the additional protocol field that lets us know what kind of protocol we're actually running. So it's essentially giving you the same information. I would recommend, however, that you use show VRF just to get yourself into that habit. So we have the right interface in that instance. Now it's time for EIGRP. So we're going to say router EIGRP. And what we're going to do is we're going to give this a name. Now let's just play around here. Let's give this a name of ISP. I'm going to say address family. What do I need to do? I'll say IPv4. Now take a look at this for a second. I have autonomous system, but then I have this VRF option. So I'm going to say VRF, and it wants a word. What's the word? L3VPN. That's our VRF, not LS. L3VPN. And let's hit the question mark. What's it want now? Now it wants an autonomous system. This autonomous system is going to be the ASN, the autonomous system of the customer that we're connecting to. Okay, it's not our own autonomous system. right? Notice that our names are different. We are the internet service provider, but the name that we are using under the VRF is Layer 3 VPN, and we're going to connect to this autonomous system number, okay? Now, what I'm going to do is I'm going to do the same exact thing that I did on router 6. I'm going to say network 10.4.6.4.0.0.0. Exit. Take a look at this. Dual exchange, EIGRP, neighbor 10.4.6.6, a new adjacency. Let's say show IP route, VRF, L3, VPN, and take a look. There are the 3 routes that are coming in from router 6 from our EIGRP adjacency. So show run section router EIGRP. Here's our EIGRP configuration. Our global instance doesn't need all of that fun stuff, autonomous system, blah, blah, blah. We need that instance, we need that configuration under the VRF. Now, we're not going to redistribute anything here just yet. Let's go over to router 5. We're going to configure the same thing. So we'll say config T, router EIGRP, we'll say ISP, address family IPv4, VRF, layer 3 VPN, autonomous system 1. Oh, I didn't create the VRF. Whoops, my bad. So we'll say VRF definition. I said I was going to show you the new way. So the new way is with VRF definition. Now, by the way, if you say VRF and you hit the question mark, you have this upgrade CLI option. This is what you would use essentially to upgrade your configuration if you wanted to. Just be careful of doing that. You may lose some IP addresses. You know, I would definitely take a backup of the interfaces that you have just to make sure that it doesn't sometimes peel off the IP address. I've seen it happen once or twice. Just be careful if you use the upgrade CLI. But we'll say VRF definition, and here's where we're going to give it a name. So we'll say L3VPN. Now, here's the thing. The route distinguisher value is still going to be the same. So I'm going to say route distinguisher, and I'm going to say is 10.5.7.0:1. But now I have a few different options here. You'll notice the addition of this address family. So I'm going to go in and I'm going to say address family IPv4, or I can go in and I can say route target. If I say route target here, this would apply globally, because under address family, I have 2 choices. I have address family for IPv4 and IPv6. I can have different route targets for both. In other words, I can have a different route target for either one, or I can have a global route target for both. If I decide to have a global route target, I have to go in and at least enable the IPv4 AFI, and I would do that just by entering the address family. Let me show you what I mean real quick. So we'll say route target, and I'm going to say export. I want to do the same as my route distinguisher. We'll say route target import, and I want to do the same. Where are you? Router 4, show run section VRF. And I want to do the same import value. I want to do this one. 5. Okay. All right, so right now, this has not actually been activated yet, because what I need to do is I need to go into the IPv4 address family and just simply activate it. Okay, I'm not going to go through all the troubleshooting to save time, but had I not done this, this VRF actually wouldn't be activated. Okay, it wouldn't actually work. So here's now a fully functional VRF under the new syntax, the upgraded CLI. So we need to do this on E01, do show run, interface E01, and we'll say VRF forwarding, and I'm going to say L3VPN. Now, peeled off the IP address, that's fine, nobody cares. Do show run interface E01, and we're good. Let's say do show VRF, lets us know, hey, IPv4, E01, here's your route distinguisher. Everything is hunky-dory. Router EIGRP ISP. Did this actually, how far did this get before it errored out? Okay, that's as far as I get. Address family IPv4, VRF, L3VPN, and we're going to say autonomous system 1, and we'll say network 10.5.7.5, and learn how to subnet. Do show run section router EIGRP. You can see that we get an adjacency. Let's say show IP route, VRF, L3VPN, and pick the right VRF. So now we're getting on the PE side, so the customer side, router 4, router 5 on the ISP side are now getting all the routes coming in from the customer. So now the next piece to this is we need to get these VRF routes into BGP. Now what we'll do is we'll pick an autonomous system of, let's say, 65,000. Okay, so that will be our autonomous system. So we'll say router BGP type 65,000, okay? And I'm going to say BGP router ID, we'll say 5.5.5. And I'm going to say BGP upgrade CLI, that will give us the newer architecture. Even though we don't have to do that, I generally like to run that macro. Now what we need to do is we need to, again, create a VRF instance, because BGP is what's going to carry these routes from PE to PE. They have to get into BGP first. Well, they can't get into BGP if I don't do redistribution, right? So I'm going to say address family. What kind of IP am I using? Am I using IPv6 or IPv4? I'm going to say IPv4. And then what am I going to do? Well, I need to create this VRF instance. So I'm going to say VRF, and then what's the name of the VRF? L3VPN. Now, all I need to do here is say redistribute EIGRP with the autonomous system and say exit. Okay? That's all I need to do with regards to BGP. In other words, getting those routes from BGP to EIGRP. Well, do show run section EIGRP. Okay? I need to get these back the other way as well. So let's get in here, get into our topology base, and I'm going to say redistribute. What am I going to do? I need to do BGP. Here's Border Gateway Protocol, right? I'm going to say redistribute BGP. What's the ASN? I'm going to say 65,000. And we need to give it a metric. Remember, EIGRP likes a metric. What's the bandwidth? I don't know. Let's say 10,000. What's the delay? I don't know. Let's say 10. What's the reliability? Well, we'll say 255. What's the load going to be? Well, the load, we'll just say it's 1. And what's the MTU going to be? Well, we'll say 1,500, right? Do show run section router EIGRP. So now we have mutual redistribution going in between BGP in that VRF and EIGRP in that VRF. And this is where, again, a lot of people get confused. The routes are now coming into this VRF from the provider. So let me actually draw. So they're coming in like this into the VRF, and then they're leaving the EIGRP VRF and they're going into this VRF here. So now they're inside BGP, okay? Once they're in BGP, now we need to create a VPN. So let me say VPN, AFI, to get them to go from router 5 to router 4. Okay, so again, it's this multi-hop. So they go from here to here inside of the EIGRP VRF. Then they need to leave EIGRP. They need to go into the BGP VRF. Then they leave the VRF. They go into the VPN. And they essentially get advertised over to router 4. And the route targets that we created are going to be these extended communities contained in these advertisements. And that's essentially how router 4 and router 5 are going to know what routes to essentially use. All right. So let's go ahead and let's create the same thing over on router 4. Whoops. Four BGP upgrade CLI. And we can probably, let's just do this. And let's take a look at our EIGRP config. We can probably just do this as well, right? Yeah, that makes sense. All right, so we're going to redistribute BGP and EIGRP on both ends. Okay, so now what we need to do, now that we have mutual redistribution going back and forth, now some people get confused here as well because you don't see the VRF. It's okay because you're in the address family for the VRF, so it doesn't matter. It's smart enough. You don't need to put the VRF at the end of your redistribution statement. Now what we need to do is we need to simply create the BGP instance, or I should say the VPN connection between router 4 and router 5. So let's say config T. We'll say router BGP 65,000. And what I'm going to do is say address family. Actually, what I'll do is I'll say neighbor. And I'm going to use the loopback. So I'm going to say neighbor 5.5.5, remote ASN 65,000, neighbor 5.5.5, update loopback 0, go to 5. Router BGP 65K. And we'll say neighbor 4.4.4, remote 65K, neighbor 4.4.4, update L0. Okay, so we should see a BGP adjacency come up, but this is not a VPN adjacency. All right, this is not a VPN adjacency. All this is doing is regular IPv4. okay? We need this address family to say VPN v4. And again, this is where some people get confused. Some people say, well, do I need this? Do I want this? You don't need an IPv4 address family in order to get layer 3 VPN to work. Some people use both because they're also transmitting IPv4 prefixes, but essentially you don't need it there for it to work. So let's actually just go in. We're going to say address family, VPN v4, and all I'm going to do is copy this activate statement. You're going to see the capabilities change in BGP, and that's okay. All right, let's go into our BGP config. We'll say VPN v4. And all I'm going to do is activate the same instance. So now we have a VPN v4 instance, and you can see that it says send community extended, because without the communities extended, without the extended communities being sent, there's no way that we could actually send the route target values across the wire. So now let's say show IP route VRF L3VPN. And you can see that now we're getting some BGP routes. So take a look at router 4. Router 4 is now getting BGP routes from router 5. Let's take a look at them. Let's say show IP, BGP, VRF, show IP, BGP, show BGP, and we'll say VPN v4, unicast, and I'm going to say VRF, and we'll say L3VPN. And what I want to do is I want to actually look at the individual prefix that I'm looking for, which is going to be, let's take a look at this guy. Okay, so now you can see that we actually are receiving these routes from BGP. It lets us know the route target. Here's that route target that we configured. So here's that extended community value that's coming in with the BGP route. So router 5 or router 4 is saying, I'm getting this route, and the extended community is 10570:1. Well, that's the community that we sent over here on router 5. This was the export community, but now we're importing it. Our VRF tells us to import it. Now, I'm not going to go through the inner label and the outer label and all that stuff. I'll do that again in other videos, but let's actually see what R6 and 7 see. Show IP route EIGRP. If I look at router 6 now has the 192.168.7 prefixes that are coming in from router 7. If I take a look at 7, show IP route EIGRP, router 7 now has the 3 prefixes that are coming in from router 6. Moment of truth. I was going to say ping, trace. There we go. Let's actually source this from our loopback 0 or loopback 1. So now you can see that you have full reachability. So let's say trace and go to the same prefix, and you can actually see the label exchange happening in your label exchange. So here, what's interesting is that this is the outer label. I just said I wasn't going to go into this. This is your outer label. So you can see that this is changing because from router 7 sends it to router 5. Router 5 sends this label packet to router 3 with a label of 315. Router 3 swaps it to 1015. Router 2 it gets to router 2. Router 2 swaps it with 215. I should say router 1 swaps it. Then we ultimately get to router 4. Router 4 has this outer or this inner label of 4022, and this is the BGP label. And this would be a whole nother video, but this is the MPLS or the layer 3 VPN BGP label that's essentially being used to know what PE router we're essentially going to go to. Okay, and again, that may be a little bit confusing, but here's the actual config. So let me just quickly show you this. So show run section router EIGRP, basic simple configuration on your customer. Let's head over to router 5. This is just a recap. Here's your EIGRP configuration on your provider. It has to be inside of a VRF. You have to configure BGP in a VRF, so it's all a step-by-step process, right? So you have to configure BGP in a VRF and mutual redistribution because those routes have to leave EIGRP and go into BGP. Once they're in BGP, the VPN v4 address family being paired with the other provider edge router will advertise these extended community values in your VRF. Here's your extended community values, your import and your export. will advertise those between the two PEs, and the PEs will decide what they want based on what address families you have configured in these VRFs. So the same process in reverse. You have EIGRP configured in a VRF, so then it's going to come out of this VPN v4. It's going to come into your BGP VRF, and because you have the redistribution statement, it's going to go into your EIGRP VRF instance, and it's of course going to form a neighbor with your customer, which is then going to allow your customer, to receive those routes. So again, guys, I know this is a really confusing video. I know that sometimes this layer 3 VPN, MPLS stuff can be confusing. I hope that I cleared it up for you. If not, I would recommend watching our entire series on layer 3 VPN so that you guys can get a full grasp on it. Enjoy. I'll talk to you guys soon.